joining us today. We're going to get started in just a minute. In the meantime, please take the next minute or so to get settled in, explore the webinar console. We have some links for you to check out, and we also have an attendee chat and a Q&A box. We are eager to answer any and all questions that you have. So if you have any questions or comments that you'd like to share, please feel free to share them in the chat or the Q&A box, and we'll get to them today. All right, we just hit noon Eastern where I am located, 11 Central. So we are going to go ahead and get started since we have a lot of exciting content to cover today. Hi, everyone. My name is Lindsay Josephs, and I work as a demand generation specialist here at OpenStax. And today we are so excited to collaborate with Aktiv Chemistry to discuss their comprehensive homework, learning, and assessment platform that coincides with John McMurray's Organic Chemistry, a 10th edition. Our presenters today are David Harris, the editor-in-chief at OpenStax, Dr. Justin Weinberg, the co-founder of Aktiv Learning, and Dr. Daniel Collins, the instructional associate professor of chemistry at Texas A&M University. I will pass it on to our wonderful presenters to introduce themselves. Why don't you go first, Justin?
Thanks so much, Lindsay. Hello, everyone. I'm Justin Weinberg, as Lindsay mentioned. I'm one of the co-founders of Aktiv Learning. I have the great fortune of spending a lot of my time interacting with faculty all across the country to introduce them to the Aktiv platform. And really excited to be here today to tell you all the exciting work that we're doing with OpenStax to integrate the new McMurry edition into Aktiv. So look forward to presenting a little bit later today.
Awesome. Thank you so much, Dr. Weinberg. Dr. Collins, would you like to introduce yourself?
Hi, I'm Dr. Dan Collins. I am a faculty member here at Texas A&M University here in College Station, Texas. Been a longtime Aktiv user, now working on about my 5th semester, trying to get it organized and built into my class as best as I can for my 2nd-year students. So looking forward to showing what I've done with the Aktiv platform and how the McMurry OER OpenStax textbook kind of fits in with that.
Thank you, Dr. Collins. We're so happy to have you here today. And David, last but not least.
Great, thank you. I'm David Harris. I'm the editor-in-chief for OpenStax. I work with the great OpenStax team and our authors developing the open education resources. And like Justin and Dan, just thrilled to be here today and really appreciate your interest in what we're doing and hopefully helping students have access through OER. So why don't we get started? Just quickly reviewing today's agenda. We're going to provide a very brief overview of OER and OpenStax, and then I'm going to provide some high-level information regarding Organic Chemistry 10E. Then we'll just spend a minute or two on ancillary support. But the real purpose today is to show how Organic Chemistry 10E, which I'm going to be calling OC 10E from here on forward, is supported with state-of-the-art courseware, Aktiv Chemistry. And then we'll have some Q&A and close. This session is really for you. So if you have any questions during this, please feel free to raise your hand or put comments in the chat, and we will do our best to accommodate. And I invite Lindsay and team to interrupt us as we're going along. All right, so why don't we get started? What is OpenStax? OpenStax, we're based at Rice University down here in Houston, Texas. We're supported by philanthropists, the Hewlett Foundation, the Gates Foundation, and governmental partners. And we're mission-oriented. Our mission is very simple. We want to provide educational access, full access to students who are focused on learning anywhere around the globe. And to date, we've published 60 books, 60 plus books, about 65 books now, that are under what are called a Creative Commons CC BY license, or one of its derivatives. What is a CC BY license? That means as an end user, you have a lot of rights. You can take it, adapt it, and then redistribute it for free to your students. And it's had a tremendous impact. To date, we've saved students over $2 billion. And I think more importantly, if you look at some of the studies, we've really helped in terms of persistence, especially Pell eligible students. So if you want to know more about what OER is, I think this definition from the Hewlett Foundation is superb and offers a great summary, that there are any type of curriculum material that's in the public domain that have no cost and very limited restrictions. Okay, so let's turn our attention to organic chemistry. And to date, we've now published the book. It published last week, and the response has been nothing short of amazing. Faculty verified their adoptions when they create an OpenStax account. And to date, we are aware of over 200 adoptions and over 15,000 students benefiting from the resource. It just published a week ago. So it's the strongest launch we've ever had of an OER resource. So you may be wondering, last year my students were paying, maybe $100 for the digital version or $250 for the print version. How did a best-selling text become openly licensed? Well, John had worked for many, many years with major publishers. And one of the things that struck him most was students who would come up to him and say, "Love your book, but it's getting very expensive, almost out of reach for him." Then in December 2022, in December 2019, John's son, Peter McMurry, he passed away from a long-term battle with cystic fibrosis. So what John wanted to do in Peter's honor was to make the book freely available to students across the globe, because he thought that would be just an absolutely wonderful legacy for Peter to leave. And that was his goal. And that's what he's done. He's worked well over a year tirelessly on this revision with us. And we're just so appreciative for that work. And we really want to honor Peter's memory. We're also thankful for Cengage for making this possible too. And so this is a very, very exciting development in OER publishing history. So if you're moved by this story, I know I would be remiss. Cystic fibrosis is a horrible disease, and John would be thrilled if you could make a small donation to the Cystic Fibrosis Foundation. John did receive payments for the rights to this resource, and he made a significant donation to the Cystic Fibrosis Foundation in Peter's honor too. So this really is philanthropy at its best. So let's turn now to the story of Organic Chemistry 10E and some of the highlights. So at a very high level, if we look at the organization of the book, it's not changed. The functional group, scope, and sequence remain unchanged. So if you've been using prior editions, this will be very familiar to you. 32 chapters in the same sequence. In terms of the major updates that John has done on this revision, like he does in all of his works, he scrutinizes every word on every page, and going through the production process with him over the last few months, I can certainly attest to that. And he made changes wherever necessary to provide maximum clarity. Also, we had a great, very diverse review panel that also gave a lot of suggestions on where we can make the text more economical, if you will, in terms of explanations. So in this slide, here's some highlights of the changes. So all of the data in the book has been factually checked for numbers for things like actually known organic chemistry, amount of chemical produced, etc. Latest scientific research have been updated. He added coverage of isophores in chapter 18, et cetera, et cetera. So as you go through the book, you'll see these updates. On the book page, we also have a list of changes to make that integration into your curricula a little bit easier. Here are some more examples of the changes, and most of the changes occurred in the second part of the book, where the science is evolving more rapidly. Okay, so what about ancillary support? So one of the biggest concerns about OER is that it does not have ancillary support with it. Well, that may have been true a decade ago, but it's no longer true. In fact, a lot of open education resources, especially at OpenStax, have more ancillary support because of community involvement than traditional resources. So with Organic Chem 10E, there will be a student solution manual. There will be also a student study guide. This has been completely redone to make it much more accessible for students who may be visually impaired. We have PowerPoint slides. We have a test bank. Of course, we're going to be talking about the online homework options with Aktiv Chemistry. And we also have a new dedicated website that integrates a DEI, diversity, equity, inclusion perspective into the curriculum. This was done by Dr. Rhett Smith at Clemson University and is completely integrated and correlated with the book. This is free to the students, and it really expands the scientific discovery through a great diversity of contributors. So we're very excited about that resource. So the question you might have is, how do my students get the resource? Well, let me just show you that very quickly now. We'll take 1 second to do it. And what you do is you just point your browser to OpenStax, and you can go to Organic Chemistry, and then you will see here book details, instructor resources, and student resources. Most of the people will stay on this page, and then you can download a PDF version, or you can view it online. I'm not going to get into the book because we're lucky that Justin's going to get into it to show you how it's integrated with Aktiv. A couple of things that you'll just note here. You'll notice that there was no password or no registration required. So this is truly open, and the students have full, unfettered access forever, which I think is a great development. And then for you, if under the instructor resources, you'll see that we have resources integrated into LMS cartridges, and then we have a host of other resources, including information about Aktiv on the website. So we invite you to go there and visit it. It is so simple to access, and that's really by design. Okay, let me move now on to the reason that we're here. And I am so thrilled to introduce you to Justin, the co-founder of Aktiv. A couple points I want to make. I don't think we would be at this point today in terms of taking a best-selling resources and making it open without Justin's support. Justin came to us very early, many years ago, probably 4 years ago, and said, David, OpenStax really needs a resource in organic chemistry. What can I do to help you? And he helped connect us to funders. He helped us connect us to supporters, reviewers, etc. And that was enormously valuable. What was also enormously valuable for us was John's initial hesitancy about moving to an OER platform like OpenStax. Because John's very savvy, and he knows that providing courseware, especially in STEM markets, is very important. And we explained to John we can't do it all of ourselves if we want to do what we do at a high level of excellence. But I can assure you, John, that we can work with an organization, it's called Chem 101 at the time, now Aktiv, that will provide state-of-the-art courseware in organic chemistry, allow students to push electrons, be able to draw mechanisms, etc. So when John saw this, I know it gave him great comfort knowing that we would be able to support the community in this way. And that's why we're just thrilled to be partnering with Justin and Aktiv, and feel very fortunate that now we're at this point. And so without further ado, I'm really excited to introduce you to Justin. Justin?
Thanks so much, David, for that kind introduction. Hello, everyone, again. I'm going to start sharing my screen here so we can hopefully get into the overview. But before I dig in, I just really want to reiterate my excitement for being here. I think honored is really the right word that I'm looking for. Just as David was thinking about, I was also thinking about when we started talking about this and we were involving John, and just thinking about the impact that this was going to have, a best-selling and one of the most popular organic chemistry textbooks out there, becoming an OER resource. And now that it's out and we're here, I can't contain my excitement for what we're doing. So really look forward to giving you all the overview of Aktiv Chemistry today, in particular, focusing on organic chemistry and really showing off the integration work that we've been working on with OpenStax to integrate the content into the platform. So with that being said, we have a lot to cover today. Just want to run through a brief agenda of what I'm going to go through before we hand it back to close and do Q&A. As always, when we do these webinars, and as I was looking through the attendees in the chat, definitely see some familiar faces. Those of you who are already using Aktiv may be familiar with it, but those of you who also may be looking at Aktiv for the first time today. So as always, going to take a couple of minutes to just briefly introduce what Aktiv is as a platform, some of its high-level use cases, and then start really diving into organic chemistry. And when we talk about organic chemistry and Aktiv, a lot of that is about drawing. It's about drawing structures. It's about drawing mechanisms. We're going to spend a good time today talking about something we've invented called the Aktiv Grid. This is a drawing system we've developed from the ground up to make molecule drawing and mechanism drawing extremely intuitive, give students incredible feedback. So we're going to go through a lot of that today. We're also going to talk about why we're here today, which is the integration of McMurry's 10th edition into Aktiv. And we're going to give you a live demo of all this. So we'll start with some slides. We'll get into what this actually looks like as a student, as an instructor, how this integration actually shows up. And then I'm really, really fortunate today to have my colleague and collaborator, Dan Collins from Texas A&M, who we've been working with for a number of years. And Dan's going to talk about how himself and the rest of his colleagues in the organic chemistry course at A&M have been incorporating Aktiv into their courses with a lot of success. Hopefully at the end of this, we'll maybe intrigue some of you to get some access to play around with Aktiv. So we'll give you some information on that and pricing, and then we'll wrap things up with Q&A at the end. We do encourage you to ask questions and participate in the chat. We are going to be going through a lot of information. So whatever you're comfortable with, if you want to post in the Q&A or start a discussion in the chat about anything that we're going through, please feel free to do that. Along with Dan, I also have my colleague, Blaine Alleluia. Some of you may know Blaine. She runs our wonderful support team. So if anyone has any questions about Aktiv as they're using it, they reach out to Blaine's team. She's going to be answering any questions that come up as we go through the content today. But if there are any questions that you want to save at the end, we can always do that and go through those as well. All right, so as I promised, just going to take a couple minutes here to go through a high-level overview of the Aktiv platform, and then we'll start diving in specifically into organic chemistry and McMurry. So one of the things that's great about Aktiv is that we're working with faculty all across the country. We recently crossed over 700 institutions where faculty have adopted the Aktiv platform for their chemistry courses. As of this fall, it's probably over 800, if not 900 at this point. But at the end of the day, we get really excited because we get to help a lot of students at the scale, whether it's community colleges, state programs, all the way through Ivy League schools. It's the reason why we got this started a number of years ago, to be able to really change the game when it comes to how students engage and interact in their chemistry courses. And when faculty and students work with us, we support a variety of courses, anything from first year in general chemistry, intro chem, GOB, of course, organic chemistry, which we're going to talk about today. We've also recently introduced biochemistry as well to the platform. While I'd love to talk about all these different courses today, we don't have time for that. So we're just going to zero in on the organic chemistry sequence today. Now, no matter what course or courses you work with us on, we have an extensive content library that you're going to get access to as faculty. We have tens of thousands of problems that cover every single topic in your course, no matter what you're covering, especially in organic, and you'll see that today. But that's not really what makes Aktiv unique, because as I'm sure many of you know, there's lots of solutions out there, lots of ways to help students practice and do assessments. They all have lots of problems and cover topics. What really makes Aktiv unique is our focus on chemistry and our focus on really solving the major teaching and learning challenges that students face every semester and every year. And in organic chemistry, as I mentioned, that is a lot about drawing. So we're going to talk a lot about the Aktiv grid drawing system, as I mentioned, that really helps students engage in drawing, makes the process intuitive, gives them great feedback. So a lot more to say on that front. We're also going to talk about the different ways faculty can adopt Aktiv within their course. One of the things that we wanted to do from the get-go with Aktiv is support learning both during class and outside of class. And that's why we have these different use cases that faculty can weave into their course depending on their style and their preferences and how their course is formatted. Now, while I'd love to go through every single detail of each one of these use cases, unfortunately don't have time to do that. So I'm just going to quickly cover things. And then if there are questions and if people want to go more in depth on something, happy to do that as well. But one of the things that is really exciting for a lot of faculty is Aktiv's ability to help them during class. This is to support and facilitate problem solving, active learning, group work, replacing worksheets, polling, really about getting students engaged and active on those personal devices when you meet with them, whether it's in person, online, hybrid, whatever it is. The vast majority of faculty also will use Aktiv to be their online homework system. Many faculty end up making a switch from a traditional publisher system to use Aktiv because of its content, its drawing, its ease of use, its mobility, a lot of the things that we're going to talk about today. We're also going to talk about the instructor side of the experience today, as much as we love to talk about the student stuff. We're going to talk about how easy it is to set up your course, our pre-made assignments, our LMS integration. So if any of you are working with Canvas, Blackboard, Moodle, D2L, we can integrate into all those systems. And if any of you also have a need for assessments, more summative assessments, quizzes and exams, we can also provide that as well. This is with algorithmic problems, question pools, randomized content, integrated proctoring if you need it. So again, don't have time to go through every single detail of one of these use cases, but happy to answer questions. What I do want to emphasize, though, is that these use cases are up to you. You can use every single thing that I'm putting up on the slide, or you can pick and choose the parts that make sense. A little bit later today, you're going to hear from Dan Collins at Texas A&M, who happens to be taking advantage of every single one of these use cases. So you can be someone like Dan, but you can also be someone who just wants something to help with homework or something to help with homework in class or whatever makes sense for you and your students. Just want to make sure that we get a high-level overview, and then we can dive into specifics. So as we get more specifically into organic chemistry today, want to make sure that everyone sort of sees the library of major topics that we offer. I'm sure for any of you teaching in an organic chemistry 1 and 2 sequence, you won't be surprised by any of the listings that I'm putting up here. It should look pretty consistent, but we have a lot of problems that cover every single topic and subtopic that you're going to care about. And if any of you are interested in getting access to the library, we'll give you information on how you can explore that and see every single detail that we offer. But while I'd love to talk about lists of topics, what I really want to talk about is drawing, as I mentioned. And a lot of that is in the Aktiv grid, which powers all the drawing that students are going to do within the Aktiv platform. So as I mentioned a couple of times now, we developed the Aktiv grid from the ground up specifically for students who are learning organic chemistry for the first time. And our number one goal was to make molecule drawing and mechanism drawing intuitive for students, because unfortunately that just isn't the case for a lot of the drawing systems out there. A lot of the drawing systems today, unfortunately, do get in the way of student learning, whether it's ease of use, grading issues, things like that. We really wanted to remove that technology barrier with this so students can focus on the chemistry, getting feedback and learning, not to technology. Another thing that was a founding principle of Aktiv was being mobile first, and that's continued to be the case for every single thing that we've done in the platform, including the Aktiv Grid. This means that students can access Aktiv and the drawing system on any single device that they want, whether it's their phone, tablet, laptop, Chromebook, desktop screen, anything that they want to use. And we always love to highlight the phone because it really opens up engagement for students. Students can be on the go, they can be commuting, they can be on campus studying with friends, they could be in class with you. It just gives them the opportunity to take out their phone and do a couple of chemistry problems, a couple of homework problems, a couple of practice problems, really allowing you to engage students in places where you might have not gotten them before. And again, do want to stress this, it's the same exact experience because of that mobile first approach, the same exact experience on that small screen as compared to a larger screen. We also made the Aktiv Grid comprehensive. It does structures, it does mechanisms, it does conformations, it does multi-step problems. You're going to see a number of examples as I get into a live demo today. I'm sure many of you are interested in seeing arrow drawing and mechanisms, which you're going to see today and a little preview here today. And we're also going to talk about feedback. We call our feedback system chemical intelligence because we have literally taught the computer chemistry to be able to grade students and not only tell them if they're right or wrong, but actually where they're going wrong. The only way for me to really show this is in a live demo, so you'll see that in just a second. As we get into the live demo, we are also going to talk about how we have integrated McMurry's 10th edition through OpenStax into the Aktiv platform. This is integrated on both the student side and the instructor side. So we'll talk about the student side real quick first, and then we'll give a little preview of the instructor side. For students, we really wanted to give access to McMurry when it matters most. When students are working through their problems, they're struggling, they don't know where to begin, and they need a high quality resource to help them get up to speed on the concepts. So anytime students are working on an active problem, whether it's a drawing problem or something else in the platform, they can simply go down to the bottom left of their screen, click on the View Textbook button in OpenStax, and it will take them directly to the section of the OpenStax McMurry 10th edition that David just showed, so they can learn more about the concept that they're working on. This is integrated for every single chapter using the online reader that David just showed that just came out last week. It's already live in the Aktiv platform for those of you using it today and anyone interested in trying it out today going forward. We have also integrated McMurry on the instructor side. We talk to faculty all across the country every day, and they are certainly very interested in moving to McMurry and saving costs for their students, but sometimes change can be hard. So we've made that extremely easy for faculty should they be interested. There's two things specifically that help with that. Number one, we have pre-made assignments for every single chapter in the book. So while these can serve as great starting points, it does give you a great idea of what a homework assignment can look like within Aktiv, and then you can edit from there, which I'll show you in the live demo. In addition to the pre-made homework assignments, which have select problems for each chapter, we have an entire library of questions. I think it's between 12 and 14,000 problems aligned to McMurry. And in addition to the problems that we've aligned, through our partnership with OpenStax, we have brought in McMurray-specific problems into the library. So you'll see a little McMurray label in the library for those problems, seeing where those problems line up with the end of chapter exercises as well. So with that being said, I'm going to hop right into a live demo showing you some of the student experience with drawing, the integration with McMurry, and the instructor setup as well. So I'll stop my slides and get into my browser here. Hopefully everyone is still able to see my screen. So what I've done here is I transitioned over to my browser where I have Aktiv Chemistry loaded as a student. I'm actually viewing things as a student, which you can see up here. And I've jumped right into one of the example problems using the Aktiv Grid. I'm going to start fairly simple here. I'm sure some of you want to see multi-step problems and mechanisms, which we're going to get to. But I just really want to give everyone a quick idea of how the Aktiv Grid works and some of the feedback that it can provide. We're going to do that through this problem, which is an example that asks students to take a structure that's given to them and draw the enantiomer of that given structure. So here I have this chirolamine on the left, and I have the grid on the right, which I'm going to use to actually come up with my answer. So the way I do that here as a student is I just start tapping on the grid lines or clicking on the grid lines. Each tap or click that I take activates a new bond and allows me to effectively lay down the skeleton of what I'm trying to draw. So as everyone is able to hopefully see here, I was able to do that pretty quickly. Now, of course, I'm not done because I have to put in my different bond types, my chiral center, my functional groups, whatever I need to actually come up with my answer here. So the way I do that is I select the part of the structure that I want to modify, and then you'll see at the bottom here, I have these different suggestions or different options that allow me to put in things like double bonds, wedge the dashes, different functional groups, rings, and things like that. And most importantly, what hopefully everyone's noticing here is that most of these options are wrong. And we are purposely doing that here because we really want the student to be thinking about the process of what they're working on. We want them to have the opportunity to make mistakes and learn from those mistakes because that's how you learn, right? In organic chemistry, especially through an active learning approach. So there's lots of wrong things I could do here, but for now, I'm just gonna put in a double bond here as I should. As you can see, I have that. I'm gonna come over here and I'm gonna make this an amine. I can make this a wedge, I can make this a dash. So as you can hopefully see, it's super easy for me to come up with these answers. But like I've emphasized, it is also completely possible for me to make mistakes. So I'm going to do something a student might do on this problem, and I'm going to submit this response. So what you'll see right away is that the system has graded me. It's told me that I'm incorrect, which I certainly am in this case. But most importantly, it's not just telling me that I'm wrong, it's telling me why. It's picking up specifically that I'm missing my chiral center. It's reminding me what an enantiomer is. It's reminding me of the CIP rules. So now I can use this information as a student to think about this and go back and try it again. So I'm going to hit retry. I'm in a demo mode right now, which is giving me as many attempts as I want. But some of you may be wondering, can I limit the number of attempts? You certainly can on the instructor side if that's what you prefer to do. But what I'm going to do is I'm going to change my answer to something different, but something that's still wrong. Again, something a student might do. The coolest part here is that as the student continues to make mistakes, even within the same problem, the system, because it is intelligent, is able to pick up on that. So now you'll see that it's appropriately telling me that I'm just drawing the same structure again, reminding me what an enantiomer is. And we can keep going with this. So, maybe I'm going to do something where I maybe mix up the concept of chirality with E and Z or cis and trans. The system will pick up on that as well. So now you'll see that the feedback will adapt yet again, and it's going to tell me that the cis or trans double bond stereoisomers are not mirror images of each other. What else would a student might do? Maybe they're going to try and take the mirror image of the structure as they're drawing it. Totally appropriate, because that's what an enantiomer is at the end of the day. But as we know with students, they're going to try and do that. They're going to make this mistake. And one of the really nice things here is that even though I'm not drawing the same exact structure as it's depicted to me in the given problem, the system, again, because it's intelligent, is able to recognize every single orientation and rotation that a student can come up with, and it's still going to be able to recognize that these two structures are chemically equivalent. Now, at this point, maybe I'm stuck, right? So maybe I don't know where to go at this point. I'm not understanding the enantiomers. That's where our McMurry integration kicks in. So as everyone's hopefully been seeing, there's this little button in the bottom left. I can click as a student, view the textbook, and it's going to take me directly to the section of McMurry that starts talking about enantiomers. And as a student, I have full access to the book, the table of contents, so I can quickly jump into different sections, go through the content, and brush up on the concepts that I'm working on. So this is present in every single problem that I'm going to be showing you today. But of course, now that I've brushed up on my concepts, I kind of get the idea. I certainly know at this point that I need to switch this dash to a wedge. And you'll see that the system does recognize my answer as a true enantiomer, even though I've taken the mirror image. That's also something that we focus on quite a bit here, is making sure that not only correct answers get the feedback, but also that correct answers, no matter which way the student draws them, whether it's left to right, rotated, take the mirror image, as long as it's chemically equivalent to the correct answer, they're going to get the credit that they deserve. So hopefully that gives everyone an idea of how the active grid works for structures, how the feedback works, how that intelligence kicks in. And with that, we're going to start jumping into some more involved problems. So the next one I typically like to show off is a multi-step synthesis problem. So again, kind of taking it up a notch from that enantiomer problem to something that's going to involve multiple concepts and multiple structures within a problem. So as you can see here, I have this roadmap that I need to fill in. I not only need to draw one structures, I need to draw three structures and also fill in a reagent. Again, I have that McMurry integration whenever I need it. So maybe if I'm completely stuck, I don't even know where to begin, I can view the textbook, and it's going to take me right to learn about Grignard's and oxidizing reagents here. But to kind of get into this a little bit, what I'm going to do here is do something that a student would commonly do, which is maybe do parts of this right and parts of it wrong. So maybe I do end up understanding this sort of Grignard component. I need magnesium and ether here. I'll draw my starting material. But maybe I'm going to have a little bit of trouble with this hydroboration oxidation section over here. So what I should be drawing here is an aldehyde, but maybe I draw a ketone instead. And with that mistake, I'll kind of follow through with the Grignard reagents and draw a tertiary alcohol instead of a secondary one. So I can submit that answer. The students will get the feedback here. What's really nice is that the students will not only see which parts they've gotten right, but also which parts they've gotten wrong. Instead of just sort of a generic message here saying, you're wrong and leaving it up to them to figure out, which parts they got right, which parts they've got wrong. It'll actually tell them, where they need to focus, which is quite nice. And in addition to that, they are going to get the feedback on every single part that they've gotten wrong and specific feedback as well. So in this case, because I've drawn that ketone instead of the aldehyde, it's going to give me messages about my regiochemistry here, thinking about where I need to put that carbonyl on the less substituted carbon, and in addition to this message here telling about the total number of carbons in the parent chain. So as a student, I can again go back in here, fix my mistakes, make this an aldehyde now. See that it updates the roadmap. Now I'm getting close to that fully correct response. And another thing we've also done with these multi-step problems is automatically grant partial credit for students as well. So instead of giving them a 0 unless they get all of it right, we actually can give them partial credit for the parts that they do get right automatically. So in this case, if I'm a student and I'm not able to figure out the entire problem, maybe I only get 3 out of the 4 parts right and I run out of time, or I just can't figure it out, I will get 3/4 of the points that the instructor yourself do assign for these problems as well, which is nice. So you don't need to regrade students or have students asking you for more points at your office hours. So we've had a lot of instructors tell us that feature alone saves them quite a bit of time. So with that, I'm going to jump into something I'm sure everyone wants to see, which is mechanisms as well. So one of the things we wanted to do with the active grid was not only make the drawing of structures a lot more intuitive, but also curved arrow drawing as well. So this is a fairly simple mechanism problem where I have a deprotonation reaction, and the system is prompting me to kind of fill in the arrows on this intermolecular reaction diagram to get to the product that I happen to have here in the bottom left. So as you can see here on the right, I have this very simple interface. As a student, I only really need to work with one button. And that one button allows me to initiate an arrow. When I initiate an arrow, what happens is that the system prompts the student to tell it where the source of electrons are for that particular atom that they're going to put in. So here I have all different options ranging from bonds and lone pairs, many wrong things, right? But as a student, I really have to think about the flow of electrons, what's the nucleophile, what's the electrophile in this case. And while I can make lots of mistakes, I'm going to put myself on the right track here and pick this lone pair on the negatively charged oxygen. Once I do that, the system then says, okay, this is where your electrons are starting. Now tell me where the electrons are going to go. What atom, what bond are these electrons going to move to? So again, I have lots of different wrong options, but I'm going to put myself on the right track here and pick the hydrogen atom on the phenol. As soon as I do that, the arrow gets drawn in. I don't need to drag across the screen or do anything like that, which can be quite frustrating for students. I just choose my starting point, my ending point, arrow gets drawn in. And then, as I'm sure some of you are wondering, well, what about the next arrow? I just click the button again. I choose my next starting point, my ending point, and the next arrow gets drawn in. Hopefully some of you are also to see that animation that kicks in, that animation showing from start to finish where the electrons are moving are really, really valuable for that conceptual understanding for students as well. Now, of course, here I can make lots of mistakes to the kind of theme we've been going through today. So I'm sure some of you have seen students, unfortunately, do things like this from time to time. And again, we have that feedback that's going to kick in to help them just really understand where they're going wrong. In this case, they're moving the electrons in the wrong direction, giving them some information to review on bond making and bond breaking as well. Doing a little time check, I do want to make sure that we show a little bit of the instructor side as well. But I know Dan wanted me to make sure I would at least show a Newman projection, so I'll just show that real quick here. In addition to skeletal structures and drawing of arrows, we have lots of questions on conformations, chairs, Newman projections, Fisher projections, Hayworth projections. I think Dan and I really love the Newman projection because students can actually rotate the Newman projection every 60 degrees to get it into whatever conformation. And then it's really, really easy for them to assign substituents across the front and the back carbon. Again, of course, to continue the theme, if they are making those mistakes, if they have those misconceptions between eclipsed and staggered conformation, as an example, they are going to get that intelligent feedback that tells them, well, you drew staggered instead of eclipsed. You need to go rotate that back carbon. So we can do that, submit our answer. There we go. All right, so I can probably talk about the student side for another hour. Do just want to make sure we get a quick view of the instructor side as well. So I've jumped into my instructor account here. Just want to give everyone a quick sense of how assignments are set up, how we work with pre-made assignments, how we've integrated McMurry specific problems into the library. So as everyone can hopefully see here, I have a little demo course here with some homework assignments set up. I'm just calling my homeworks homework 1 through 4 here. Let's say I'm an instructor, I want to build something from scratch. I just click on new activity over here. I can title my homework. Next one in the series is going to be homework 5. What's really nice here is that you're getting to see our new assignment setup process, which allows you to get convenient access to all of your settings on the left-hand side panel and then all of your content on the right. So I've titled my assignment, and you'll immediately see on the left-hand side, I can start looking through things like my due date. So maybe I want that to be due October 20th at everyone's favorite time, right before midnight. I have all different settings here. I'd love to talk about that, but unfortunately I don't have time. I do want to point us to our resources section here, which is important for our McMurry integration. So if I want that McMurray link for my students, I just enable my extra resource link, and I have a number of options here, and I'm going to pick McMurray, and that's how I create that integration for my students. Now, of course, here I got to add in some problems, so I'm going to add in problems here on the right-hand side. It takes me right into the library, and I've already filtered things for the McMurray book. So what our content team has done is align all of our content, pulled in McMurray-specific problems, so that you're seeing the table of contents of McMurray and how all of our content, our tens of thousands of problems, have aligned to each chapter and section. So if I'm looking for content in Chapter 7, I just go into that section. Maybe I need to pull from section 7.8, and you'll immediately see problems. As I mentioned, there's a lot of problems in here, but some of them specifically will have that McMurray label. And in the description, you'll see how that McMurray problem lines up to the end of chapter. This one happens to be the end of chapter 7, problem number 25 in the description. So if I want that added into my assignment that I'm building, I just simply click the add button, and I can continue to do that for as many problems as I want. So it's a really, really simple process. Now, if I'm an instructor, I want to take a deeper look at one of these problems, I simply just click on it, and I can choose to see kind of what that looks like before I decide to add it into my assignment or not. But if you're confident just from the description, which a lot of our instructors are, they can simply just add and remove whatever they need right on the content list here. So that's the process of building an assignment. Once I click done, you'll see all the problems as they've been loaded in based on the order that I've picked them. And then I can simply save this and go back to my list, and you'll see homework 5 right here as well. Now, in addition to building homework assignments from scratch, our team, as I mentioned, has also made a set of pre-made assignments for every single chapter of McMurray. And if anyone is interested in getting access to these to see what active assignments would look like with McMurray, we can provide you those, and we'll give you no information on how that works in just a second. So as I mentioned, we have assignments here for every single chapter. we'll stick with chapter 7 just to continue the theme. If I want to go in and edit these, I can see all the problems here. I can check them out, see what they look like. If I want to remove them from the assignment, if I want to go add more problems into the library, I have complete freedom to do that. If I want to edit the due dates, any of the grading policies, which if any of you have questions, we can get into. But it's just super easy to get an idea of how this works. And with that, I want to make sure that we get over to Dan. So while I'm sure many of you have questions, we'll stop sharing for now. And what I'm going to do is introduce my colleague here, Dan from Texas A&M, who's going to tell us a little bit more about how he's been working with Aktiv and the McMurry book with his students. I had the great fortune of visiting Dan's class a couple years ago when we were getting started in organic chemistry, and actually see some of his students interacting with the Aktiv grid, actually seeing students smiling doing organic chemistry, as you can see, which we'd all love to see every day. So with that, I'm going to hand it over to Dan to tell us more about how he's been using Aktiv.
Awesome. Thank you, Justin. Really appreciate it. Blessed to be a part of this experience and working with you guys and now with OpenStax. So to kind of give a little bit of the history of where we are at A&M, we have a very robust and large chemistry program. In the fall of 2023, our freshman class that we entered, and I'm going to wait a minute so people can understand exactly how big this number is, we put in and brought in 14,000 freshmen. Normally, somewhere in the ballpark of that, we have 9,000 to 10,000 of those taking freshman chemistry. So when you extrapolate that out and you get to organic, currently right now we have 20 sections of organic chemistry ranging from enrollments from 100 to somewhere in the 200s to 250s. My specialty is teaching those large courses. As you can see here in some of the pictures, we have unbelievably great resources here at A&M. We have large teaching environments where students can write on the whiteboard tables. But what always seemed to be lacking for me was I wanted a homework system that was more robust. But one of the big concerns that we always kept seeing in here is that I felt like I was nickeling and diming my students. $30 for a homework and $10 for a model kit, and it just never seemed like that they got the consistency that they needed. Another side of this is I hated the fact that when we got during the COVID era, they're signing up for quizzes on Canvas, homework on our OWL program, doing exams on a different platform. So for me, it was trying to consolidate and make it as user-friendly as possible. Blessed enough as it was, Justin and Eric Gates, who is one of the marketing people with Aktiv, came to me and said, "Hey, Dan, can we try this?" And I jumped on board this immediately as I could. So, Justin, if you want to head off to the first slide there, where I'll show you kind of what I normally do for a lay of the land. You're going to find out that I use this as comprehensive as probably as any Aktiv user out there. What I am probably best known for prior to what I was doing in class is I was very big about using online media and doing what a lot of people will call a flipped classroom. I would build online content videos that especially became incredibly useful during the COVID era, that I want to get basic fundamental material that I know that my students can handle. But how do we gauge that? How do we check to see if they are actually going and watching those videos? So for every one of my lectures, which I normally have about 30 in the course of a semester, I will put out a pre-class assignment. As you can see, 3 or 4 questions. They get unlimited number of attempts on the questions on these type of assignments. I'm not here to penalize them. I want them walking in the door and saying, "Hey, do I know the material that I need to be successful in class?" So what's nice about this is that these assignments could augment to the online videos I already had produced. If there are individuals that want access to those videos, I'm actually going to go and put my email in the chat box right now so you guys can reach out to me. I'm one of those that I love getting those videos out and helping people publish good videos, because I think we all were kind of caught a little behind during that COVID era and when we were first starting to teach online. I'm just blessed that I got there 2 years or 3 years in advance. So now this sets my students up for success when they come to class. So Justin, if you want to go to the next slide, what's nice about this is that once they get into class, now we can do what some people will say is that atypical lecture. My lectures are 75 minutes. I can talk a lot, but that doesn't help my students. Especially I teach at 8 a.m. and at 9:35 in the morning. Now, the only students that are really awake at that time happen to be our Corps of Cadets, and I have about 5 of those of my 240 some students. So what's interesting about this is I needed to find a way to break up the monotony of a classic lecture. So historically, what I will do is now build off that material that I had online and go to some harder examples, whether we're doing naming. As you can see here, this is actually a question that I just took from a recent class in which I was doing stereochemistry. So it's now saying, hey, you have this material, but now let's go and push those bounds a little bit more. So that way a student feels like they're getting something out of class. Maybe it's lecture for 10 or 15 minutes, then we go and do a question. Big thing for me is, hey, I may talk about a mechanism that may be difficult and shouldn't be talked about on a video. Hey, that's great. Let's go and talk about that in lecture and then do an example problem right behind it. So what's neat about this is I was able to have this dynamic class where students could be able to draw on a platform they're used to already, but we can do it in class. Prior to this, I used an iClicker. I think every faculty member out there has used that type of platform at some point. But then my students weren't being able to draw. They weren't being able to see that comparison of, oh gosh, I put the double bond in the wrong place. This allows them to do that. So for me, I'm able to pull up those results, see who's interacting, see where those misconceptions are. This has turned my class into actually a fun experience instead of 75 minutes of just feeling like I'm talking to them. So now we get done with the lecture. How do I help them? Well, I'm one of those that believes that we should escalate their difficulty. So obviously we bring in a homework. Before, I'd have an iClicker, then I'd have a homework system. No, let's put it all in one place. One of the things I absolutely love with Aktiv and now with the OpenStax integration is now not only do we have those problems that are associated with the McMurry text, one of the things that we were finding out because we had so many sections of organic chemistry is, did we have the same learning objections? Did we have the same consistency between 8, 10, 12 faculty members? Well, Justin will tell you, we actually now have certain common problems in our homework sets that go for every faculty member. So now when a administration comes to us and say, hey, are you going through the same learning goals? We actually are going to have that data. So that's huge for me. Other thing that I also love about this homework, and I want to take the time to show it in here, is the 2 things I've highlighted here on the screen. First off, I'm one of those that we know our students aren't just students anymore. They're working jobs. They may be taking care of family. We've seen in this post-COVID era that our priorities are a little different. I don't want to sit there and wail on them on a homework over and over and over and feel like that I'm just taking all of their time. So one of the things that Aktiv does very well is they are going to take and give a suggested total time to the assignment. What's awesome about that is I typically build my homeworks for about an hour in length. So as you can see for this homework, based off of this, it should take hopefully a student about an hour, 6 hours, 7 minutes in there. That way, if I find out that they're taking 2, 3 hours on this, I can go and talk to them about those fundamental problems. Where are they making the mistakes? The other side about this is, because my courses are so big, I love that I can build problem pools. Let's say that you're worried a little bit about academic integrity. Right here at A&M, we have a huge, huge population, but we also have our Aggie Code of Honor, which is a very big thing. We want our students to do this with integrity. I'm able to build problem pools in which it rotates through the students. So that way student A may be getting one naming problem where student B may be getting another. You can add this dynamic easily into the homework, so that way it's mixing it up a little bit. So if you do have a course and you're worried about student just getting all the answers and going on there, well, there is a little bit of combat to that. The big thing about this is you've seen with the resources and the flexibility. Historically, when I get my homework, I let my students have 3 attempts per question. Reason why I'm a little stringent on that is I actually go and build a new supplemental problem site. So Justin, if you want to flip to the next slide here, you're now seeing one of the things that I'm just so proud of, and shows you how far Aktiv's come in the 5 semesters that I've worked with them. My students only get 3 attempts on the graded homework because now I'm building a supplemental, try as many times as you want, try it any way you like, practice problem set. This gets me out of the way. They're not coming to me saying, oh, Dr. Collins, we need more questions on RS notation or finding chiral centers or what's the relationship between a diastereomer and an enantiomer. I'm now able to go, because the pool is so large, that I can handpick problems that are similar but not going to show up in the homework. What this allows me to do is if I see a student is struggling with a problem, hey, have you done the practice problems? Oh, no, I haven't done those. Work on those, save your attempts on the homework. That way you can feel a little bit more confident, get a little bit better, see what you're doing wrong. Then you can go back to the homework set in there. So what's so great about this is now this problem pool is so large that you're able to go and build different assignments, maybe that might be extra credit as you get later towards the end of the semester, but it really helps the students in a very, very poignant way. Now, the last thing I'll show you real quick in here is my quizzes. One of the things that I wanted to really highlight in here and go forward is that, as I talked about before, escalation of difficulty. I want to push my students because as they're getting ready for my exams, we want to see their skills getting better. So what I can do is, after I finished a chapter in the McMurry text, normally that takes me about a week in the lecture, I will put a quiz out probably be about 5 to 7 days after. I want to see if they're still working on this material. I want to see if they're forgetting stuff. What's nice about this is as you start delving into the problems on the Aktiv, they'll actually say their difficulty level of easy. You'll notice that I used a lot of those easy ones for my problems in the early phase of my course. But now as we're getting towards the exam, and I know I can write some very robust exams, one of the things that's so important is now picking quiz questions that build off of stuff that may become multi-part, multi-conceptual. So for me, it was making sure that I used a system that could do all of this. As Justin said earlier ago, maybe if you're sitting there going and saying, hey, I just like to use this for quizzes, or I just want to use this for homework, you can do that. You have the flexibility. I am just blessed that I have my current administration here at A&M, the blessing of Aktiv and all that. I'm able to go and use this every way possible that I need in the course. One of the big things that I want to say to all this, and I know that we're running out of time and everything, I honestly just want to thank all of you for attending. This is a wonderful system, and this is a wonderful collaboration between OpenStax, between Aktiv. I am just truly blessed that I got in on the early side of this. It was a textbook we were already using here at Texas A&M, and I am so thankful to John McMurry for what he's done in honoring his son, and truthfully what Justin and everybody's talked about today. If you ever have questions, feel free to email me. I'm very easy to find, and I truly appreciate your time today. Thanks, guys.
Thanks so much, Stan. Really appreciate everything that you've shared about how you've been taking advantage of Aktiv. So as Dan mentioned, if you want to be comprehensive like him, you could do that. If you wanted to be flexible and sort of focus on some of these sub-use cases, you could do that as well. I think that's so important and such an important aspect of how we've built Aktiv. So I know we're brushing up against the hour, or running up against the hour. As promised, do you want to give some information about how you all can get access to everything that you've seen today? We are actually doing something pretty special, actually something that we've never done with Aktiv before, which is offering completely free pilots for anyone who is interested in using Aktiv and the McMurry integration this fall. So if any of you are interested in trying this out with your students in the middle of the semester to take advantage of the drawing, the mechanisms, the links to the textbook, the pre-made assignments, you can get access to all of it completely no cost to your students anytime this fall. And the way you can do that, if you're interested, is by following this link. So my colleague Blaine is going to paste this link into a chat. It takes you to a calendar. You can register for some time to meet with us. You can set up your pilot, get access to an account, get access to pre-made assignments, and you can use anything that you want with Aktiv, no cost to your students. So that link is in the chat. We've also put a QR code for any of you interested in just picking up your smartphone camera and pointing it there. You can do that as well, same link. We're also going to send this link out in an email to everyone following this webinar if you want to pick that up as well. Now, for those of you thinking about post-fall, thinking about spring, thinking about summer, thinking about next fall or beyond that, we'll talk a little bit about pricing. We have worked very, very hard with OpenStax to make Aktiv extremely affordable for all students. The pricing is as follows. We have pricing for schools on the semester calendar and for schools on the quarter calendar. We'll just kind of start with the semester calendar, and for those of you who happen to be teaching quarter calendars, the same mechanism follows. $42 for students' first semester of use, and then $33 for any additional term that they take after that. So if we just talk about organic chemistry, students may take organic 1. They sign up for Aktiv, they pay $42 for that first semester. When they take organic 2, if they take organic 2, if that's a requirement for them or they're going to make it in that semester, we automatically discount their second term price to $33. What gets even better is for those of you in institutions where Aktiv may be used in first year courses, especially in general chemistry. If that's the case, this $33 discounted pricing will roll in from their first year, meaning that once they get into organic chemistry and they've already used it for Gen Chem, they're going to start paying $33 right off the bat. But if you just start with organic, it's $42 for that first term. This includes everything in the system that we've talked about today, and including a lot of things that we honestly didn't have time to talk about today, like our adaptive follow-up, our integrated proctoring if you need it. I do also want to stress that this is lifetime access for students. This is incredibly important for those teaching and learning in organic chemistry because students are often going to take the MCAT or another professional exam. Because we give lifetime access to all students, they retain access to their course materials even after the course is over. So they can look back and practice problems and do all the things that were available to them when they need to review and they need to brush up on a prior semester. We also enable students to pay in any way that you prefer: inclusive access, day one access, direct student payments online, bookstore codes. We have a 2-week grace period. We give amazing support for all of our faculty, including personalized onboarding. So we can talk about this for quite a bit. But I know we're right at the hour. Again, do want to reiterate that offer for free pilots. And also for those of you who are just interested in getting access, maybe you don't want to do it this fall, but maybe you're thinking about this for spring, for summer. You just want to get access to this thing, see the problem, see the pre-made assignments, see the link for students, test out the drawing. Follow that link as well. We'll set you up with an instructor account for free with all the McMurry integration that you've seen today, and we'll gladly give you access. So Blaine will post that in the chat. Again, if anyone wants to just scan the QR code or look for the link in the email that follows this webinar, we'll do that as well. But with that, we'll use any remaining time. Thanks for those of you who are sticking around. We still have quite a lot of people here. We'd love to do any questions that people want to put in the chat or in the Q&A section, and then we'll close up with some more information on OpenStax. So we'll do a quick scan in the chat here. All right, so I'm just going to go from the bottom here and scroll up. So I saw a question from Jason. Can students cut and paste reactions or mechanisms from the platform as they are required to submit labs online and need a drawing program? So what we're definitely seeing a lot of students do is go in the Aktiv grid and take screenshots, which they're very accustomed to doing these days, trust me, and then they can cut and paste those into a Word document or submit it online or anything like that. We definitely have students doing that. All right. Saw a question from Matthew Davis about how the discount works. Does that discount work if they buy one term at a time, or do they need to buy both terms at the same time to get the discount? they do not need to buy both terms at the same time to get the discount. Students pay for active as the semester happens, right? So first semester they pay 42. When they come back and take that second term, that's when that discounted pricing kicks in, and they'll pay 33 automatically. Would this work if we have a 1-2-2-1 system? Yes, it will. So if you're in an institution where you're teaching Gen Chem 1, then Organic 1, then Organic 2, then Gen Chem again, or any combination of those things, we do support that as well. It doesn't matter what sequence. First term for active is 42, and then 33, any additional term after that. Is OpenStax or Aktiv available in Europe? I'm interested in discussing the possibilities. OpenStax is available globally. I'll say for Aktiv, most of our users do come from North America, but we're happy to work with anyone overseas as well, in Europe or any other country. It will be English. We don't have any localization in any other language, if that's a question, but we're happy to work with you if you're interested. So please grab some time in the link. Did see a question from Nick about embedding into the LMS. Yes, we do have LMS integration. We work with Canvas, Blackboard, Moodle, D2L, and many other systems, so we can get that integration in for you if that's something you want, and many of our faculty do. All right, so I'm seeing some new questions here. Are discounts tracked by email address? So they are tracked by account, which includes an email. So yes, in a sense they are. If you purchase the Aktiv Chemistry license, you automatically have access to McMurry 5th edition. Yes, everything is included with Aktiv, including the McMurry integration. How about students that take 2 courses in 1 semester, 8-week courses, as an example? So our access is not based on time, it's based on courses or content. So if you have 2 8-week courses within a traditional 16-week semester or fall semester, the students would be paying twice for that. And that is because we do lifetime access, so students retain access to all the content no matter what. It's not based on time. Another question about the integration. Is the integration just grade reporting, or can you embed questions or challenges into the LMS? So the questions, the integration for LMS certainly includes grade syncing, so that you can get any number of columns and grades reported back into your Canvas gradebook or Blackboard gradebook, whatever it needs. But it also links to the assignments as well. So all the assignments do show up in Canvas. Students click a link, they're taken right into Aktiv there as well. And if any of you have questions about how does this policy work, how do I set up points, how do I integrate with LMS, how does this gradebook work, those are really good questions that we can answer for you with some time. You can explore the account, see how things work. So again, do you want to make sure that everyone gets that link if they're interested in getting access and learning more. Got a question from Jason about is Aktiv available through Follett access, which would be inclusive access, day 1 access. We work with all those programs, and we have been doing that for a number of years. So we can set it up with whatever payment mechanism that you need: day 1 access, inclusive access, bookstore codes, direct student payments online, department pay, anything that you desire. If a student needs to retake a class, will they have access to their previous content, or will they have to pay again for access? So that's part of that lifetime access that I was talking about. Students do not need to pay again to get access to their previous content. As soon as they pay for the content, pay for their course, they get access to it for as long as they need. So a year or 2 later, after they're done taking your organic chemistry course, they're studying for the MCAT, they can get access to all of their material. We do not charge them any additional amounts for that.
Great.
Really appreciate all the questions. I know we're going a little bit over, which is great. We still have many of you here. So if I can ask Blaine to maybe put that link in the chat, if you just want to talk to us and ask questions, get access, sign up for your free pilot, please take advantage of that. We'll send this out as well. I know David wants to wrap up with a couple of comments and things about OpenStax. So I'll start sharing my screen here, and I'll hand it back over to David to close this out.
Great. Thank you so much. Certainly a wealth of information. And as I said earlier, we're very excited to be partnering with you. You'll get a survey about this webinar. Please fill it out. And if you're interested in delving deeper into a specific topic with Aktiv, let us know. There's so much interest in these resources that we could certainly see if we could do like a in-depth webinar on specific areas, because we understand there's so much to cover. Okay, so just in closing, thank you so much for attending today. We really appreciate it. And people always say when it comes to OpenStax, you know, what's the catch here? Well, there's no catch. But the one thing we'd asked is OpenStax, we're a small nonprofit. We don't have a large sales group. And so it really helps if you spread the word. If you like what you see or like what we're doing, please recommend us to a colleague or a student, and we're here to help them out. And if you have any questions, it's just info@openstax.org. So I think that wraps it up today. Thank you so much for attending, and we really look forward to helping you out in the years ahead. Thank you very much.
Thank you, everyone.